So atoms have a specific structure. They have a central dense nucleus surrounded by orbiting electrons found on electron shells. So now let's look at the atomic structure in a bit more detail. So the nucleus contains two types of particles. They are the proton, which has a positive charge, and the neutron, which is neutral. And they're surrounded by the electrons, which have a -1 charge. So overall, the nucleus has a positive charge, because you've got positive protons, and the neutrons are neutral. And obviously they're surrounded by the electrons, which have a negative charge, and they're found in the electron shells. So if you notice, the number of protons is equal to the number of electrons. So this means that overall, the atom is neutral. And this is the same for all atoms. Now what keeps the atom together are those attractions between the positive nucleus and the negative electrons. So we know that atoms are really small, but subatomic particles are even smaller. So let's have a look at their mass. So the mass of one proton is 1.67 times 10 to the minus 24 grams. That's really small. And the mass of one neutron is exactly the same. Now the mass of an electron is even smaller, in fact 2,000 times smaller. So it's not practical to use these really small numbers. So what we use is a ratio. So if you notice, the mass of a proton is equal to the mass of the neutron. So as a ratio, that would be 1 to 1. So we say that the atomic mass unit of a proton is 1, and the atomic mass unit of a neutron is 1. So next, let's look at the electron. If you look at the mass, you notice that the mass of an electron is 1/2000th of a proton and a neutron. Therefore, the atomic mass unit must also be 1/2000th of that of a proton or a neutron. And so it's 1/2000. So now let's have a little check of what you've learned so far. Try and fill in this table. So here are the answers, and an easy way to remember the charges. Now a proton begins with P, and so it's positive, +1. And the word neutron has neutra in it, it's neutral. And what's left over? The electron, which is -1. So remember, those actual masses are those really, really small numbers, which are far too little for us to deal with. So instead we use the ratio of the masses, known as atomic mass unit. Now remember, the mass of a neutron and a proton are the same, so relative to each other they are 1 to 1. So the atomic mass unit of a proton is 1, and the atomic mass unit of a neutron is 1. The electron is 2,000 times smaller than the proton and the neutron, so its atomic mass unit is 1/2000. So atoms make up the elements, and the elements are found in the periodic table. Now, there are lots of elements, and they're all different, but each individual element consists of the same type of atom. That is, the atom of an element will always have the same number of protons and the same number of electrons. So let's look at how we work out the number of protons, neutrons and electrons in the atoms of a certain element. The proton, also known as atomic number, tells you the number of protons in an atom. And the nucleon, or mass number, tells you the number of protons and neutrons in an atom. Notice that nucleon is like the word nucleus, so it's talking about the things that are contained in the nucleus. Now using these numbers, we can work out the number of protons and the number of neutrons in an atom. So now let's look at an example, and let's use lithium because we've drawn that already. Now you can see that lithium has 3 protons, and it has a proton number of 3. And we can see that it has a nucleon number of 7. Now, if the nucleon number is the number of protons and neutrons, we know that if we take the nucleon number and detract the proton number from it, 7 minus 3, that will give us the number of neutrons, which is 4. So what about the number of electrons? Well, we know that atoms are neutral, And we know that the charge of a proton is +1 and the charge of an electron is -1. So those charges have to balance. Therefore, the number of electrons must equal the number of protons. So, if we know the number of protons, we also know the number of electrons. Therefore, the proton number also stands for the number of electrons. So if the proton number is 3, the number of electrons is 3. So this all makes sense in terms of atomic mass units. We know the AMU of a proton is 1 and the AMU of a neutron is 1. So if the number of protons is 3, the proton number must be 3 times 1, which is 3. And if the number of neutrons and protons is 4 and 3, then we know that the nucleon number must be 4 times 1, 4, plus 3 times 1, 3, is 7. So let's see if you can put this theory into practice and try and fill out this table. You should probably use a periodic table to help you. So here are the answers. From the periodic table we know the proton number of magnesium is 12 and the nucleon number is 24. Number of protons is the proton number, 12. The number of neutrons is the nucleon number minus the proton, 24 minus 12 equals 12. Now, we know the number of electrons must equal the number of protons, so it's 12. And here are the rest of the answers. How did you do? That brings atomic structure to an end. Thanks very much.